Hello again to the Rendezvous workshop, where today we're going to be talking about the Oasis Privacy Layer hackathon. So the hackathon is launching today, and it's for 2 months, so 8 weeks of time you have to hack away. There's $30 in prizes across 4 categories, and that's paid in cryptocurrency, of course. And then there's $25,000 worth of crypto for follow-on grants and support, and not just the winners, but the runners-up too. So the 4 different categories we have, which is the best app on Sapphire, the best app that uses OPL, the best use of Sapphire for scalable privacy, and that includes ZK, MPC, anything you can do with a trusted execution environment, and integration with bridges or to other networks, and then tutorials and standards. So for the standards, there's a lot of small differences between confidential EVM and what you're used to on Ethereum. But at the same time, the standards on Ethereum have been around for quite a long time, and they're starting to show their age. So if you want to have a look at maybe reimagining some standards, that's a good time to do it, and there are some interesting ideas out there. So in terms of follow-on grants, you can get sort of extra support from the Oasis Foundation, which includes marketing support, code reviews and testing from experts, or some problem solving as well. You can get featured on the community town halls, and of course there's job opportunities for interested people. So for the 8 weeks of building, we expect the submissions to be in by September the 13th, that's the end of the day, with judging beginning, judging sort of ends about 2 weeks later, with the winners announced on October the 2nd in the morning. And to submit, you want to submit a 3-minute video along with the description of your submission. So the video should be a walkthrough, or sort of describing the features, some of the problems that you encountered, and how you overcame them. And along with the submission, you need to submit a GitHub repo. So the code must be open source. It doesn't have to be GitHub, it could be GitLab, it depends. But you need to include a README along with the testing instructions and a live demo link. So if you're doing a standard, you might not have a live demo link, but we do expect some sort of tests, some sort of documentation. It's got to be finished, you know. So in terms of ideas, there's lots of different things to pick from. We've got DAOs and gaming and decentralized identity and NFTs and DeFi. So anything to do with privacy or sort of confidentiality and governance, this can all be done. But then you can also look at compliance. So think of like doing US dollar and regulators. It's an interesting area, especially when you have privacy. So there's options to maybe show the regulator some parts of the transaction while keeping the information safe from phishers. So generally secured information passing, and then stateless contracts or TOTP. So you can't do TOTP on any other blockchain because you need to have a secret. And of course, bridgeless bridges. And you can ask ChatGPT for ideas, but basically a Discord is a good place. You can follow us on Twitter, or you can ask on the forum. And does anybody have any hackathon questions? No? But if you want to ask them on Discord, please drop in and we'll get an answer to you. So Sapphire and OPL, which is a private and cross-chain. I know some of this material has been covered before in the talk, but we're going to go through the sort of compute layer. So we're focusing on Sapphire, which is secured by the Oasis architecture and the Oasis verifiable compute layer. So it is an L1 blockchain, and everything's secure using the trusted execution environment to execute EVM-compatible contracts inside the confidential EVM. But why TE? So in terms of the sweet spot for general-purpose computation versus performance, if you trust the hardware, and this is physical security, you get so much more performance versus secure multi-party computation, which requires lots of messages in between sort of live participants, or ZK proofs, where it gets exponentially more complicated to prove the larger your program size gets, and fully homomorphic encryption and computation, which is still early days. So that's probably where ZK snarks were maybe 7 or 8 years ago, and it's not quite there at the moment. So Sapphire, of course, we've got the contract state, which is protected by the trust execution environment, and it gives you almost identical experience to Ethereum. And because it's Oasis, you get high scalability, fairly low fees, and you get access to all of the precompiles, such as the random number generator, signing and encryption, and of course, encrypted transactions prevent front running. So if you want the best of both worlds, let's use Sapphire. And what's OPL? So OPL is a message bridging contract protocol between one contract on Sapphire and one contract on any other chain. So we support a fairly wide variety of chains. And it allows you to selectively encrypt part of your application or to selectively use the capabilities of Sapphire that you can't use on other chains while keeping your assets on a chain that's where your users are. So it allows a sort of a degree of transparency, a degree of convenience, because we don't have to pay for gas directly from the users, because the bridging mechanism itself will pay for gas on their behalf. And it works where you register your contract with OPL, you register which methods can be called, and then other contracts which are connected to your contract using the OPL bridge can send messages across, and they'll be executed by the Sealer IM executor. And it takes a couple of minutes, but that's blockchain reality. So here's a sort of overview of this, where with the OPL in combination with the message passing bridge and the gas relay or the gasless contracts, you can have your application on the home network, and you can only put if you want to, you can put the parts of your contract that require sort of confidentiality on Sapphire, and the experience should be fairly transparent in terms of not requiring you to add networks in MetaMask or require different gas tokens. So the Sapphire confidential EVM, which is, we have the Explorer, we have a new Explorer which we'll be demoing soon. And if you want to get started for development, there's a faucet, so you can go to the faucet.testnet.oasis.dev, and it will give you some free testnet coins. There are lots of examples that we're sort of pushing out, and the documentation is a very good resource to get started with, because it covers quick start examples, walks you through the installation process, and if you get stuck with anything, the documentation and Discord or the forums are a good place to ask. So to get started, you want to go to the Oasis Protocol website and click Add Sapphire, or if you're a dApp developer, you want to add the Sapphire-Paratime package to your project to get started. So what are we going to cover today? Well, it's authentication, confidential state, the precompiles, random numbers, key pairs and signatures, and encryption and decryption. But to start with, there's authentication. So I think this has been covered a bit, but there's 3 different ways. So the view calls, then signed view calls, and transactions. And on Ethereum, there are only 2, which is view calls which don't modify state and transactions which do modify state. So the view calls are anonymous and they're unauthenticated, which means you don't know who's calling them. So it's if we allowed anybody to choose any message.sender that they wanted to and call the contract, they could get the contract to leak secrets or pretend to be you. And with confidential contracts, that's a big security problem, because you don't want people to gain access to stuff they shouldn't have access to. So we have signed view calls where it's stateless, as in you can't modify state, but you get authentication on top of that. And then with transactions, we support EIP 155 along with 2718, and we're pretty much compatible on the transaction level with all of the existing tooling out there that supports Ethereum and unencrypted transactions. But there's Sapphire-specific encryption, so that's it wraps the transactions and the call data with encryption. So that means nobody can see the call data on chain, but the sender and receiver and the gas price are not encrypted. So if you want to be careful about anonymity, just be wary that we know who's executing transactions and how much gas it costs. And that can lead to interesting things if you're not careful. but all transactions are authenticated. So we have confidential state, which anything that's private or internal is confidential, but you have to provide the public view functions to access the private state and implement access control. So because the contract's confidential, you can use passwords or like TOTP to implement access controls. So if we have a quick look at how is confidential state, well, we have the key manager. So the contract uses the Oasis Paradigm SDK to request the key for the specific item that it wants to access from storage from the key manager. It then pulls the encrypted value from the key value database and decrypts it, but the decryption is inside of the Sapphire trusted execution environment. So a quick example of this is you've got a contract, you can set some state, and this is all private. But then if you want to add an access method, you could use a signature verification to ensure that the person who previously set the value is trying to retrieve it. So it doesn't have to be that complicated, but for most contracts, you can just change your variables to private, and then let users pay gas for the transactions, and there's not a significant sort of hurdle to take advantage of confidential contracts. But so for the precompiles, you can add the Sapphire-contracts package to your dApp and import the Sapphire.sol library to get access to the precompiles. And all the documentation is available, which shows you what the precompile addresses are, the call formats, and how to use them. And of course, to use the precompiles and test them, you're going to have to use the Sapphire dev Docker image, which runs the full Sapphire stack locally. So what are precompiles? They're ways that extend the EVM. So Solidity only has basic operations, but the more complex operations, such as the elliptic curve pairing or the EC recover signature verification or even SHA-256, these are additional contracts at fixed addresses that are sort of very fast and built into the EVM. But in Sapphire, again, we have encryption, decryption. We have elliptic curve Diffie-Hellman. We have key generation for the twisted Edwards curve and the SecP curves used on Ethereum and Bitcoin. And of course, signing and verification for those curves and random number generation. So for random numbers, it is cryptographically secure, and you can personalize the entropy. So if the user wants to pass in extra entropy to make sure that it's more random, then they can do that as well. But a bad example is you have to be wary of how you're using the random data. So if you're creating a game where you spin the dice and see do they win or do they lose, because there's lots of interesting hackers out there, you could just create a contract that spins the dice with the bet, and if you don't like the outcome and if you don't win, you just revert, which means that it's possible to make it win every time. So in a situation like that, you'd want to use a sort of commit and the reveal pattern where you commit to the random data and add your bet or whatever, and then you reveal it, which prevents them from exploiting that. And it's much easier than VRFs on all of the other chains, because you don't need the call to go out to the VRF and then come back. It's instant. So on to signing in encryption and decryption, where we're using X25519 key pairs to derive the shared secrets. And you can see an example here on GitHub, which goes through sort of this encryption process. So there's lots of interesting use cases. I think it's any way that you'd use encryption, you can also use it on Sapphire. So ECDH, I think it's just one of these fundamentals that you have to wrap your head around, which is if two people have key pairs and they only have to share the public keys with each other, as long as they only have their, as long as one person can, as long as both people have their own secrets and the other person has the public, they can both come to the same answer. And then a hash of this operation is used as the shared secret between them. So for decryption solidity, we can generate the ECDH key pair, and then we provide an access to get the key pair for the contract. So in order to decrypt something, The contract would then go through, it derives the symmetric key using the ephemeral public key that's passed in and its own private key, and then it uses that to decrypt the plaintext. And this is really quite simple from TypeScript. So we call the getPublicKey. We attach to the ephemeral public key to that, and then an ephemeral key pair, do the encryption, send it through along with the nonce. So for signing and verification, so the contracts, they can generate key pairs and they can sign with ECDSA and EDDSA, and there's lots of very, very interesting use cases. So like with encryption, anywhere you can use encryption, anywhere you can use signing, you can also use it here. But I think it's a little bit more interesting. So you can generate Ethereum addresses, you can sign transactions, you can use WebAuthn and Touch ID. So WebAuthn and Touch ID, that's on pretty much every phone that's made by Apple and Android in the past 5 years, supports EDDSA that's secured by your fingerprint and sometimes your face. And that means you can use it as a trusted oracle if somebody else on another chain trusts your contract's public key, you can broadcast information over there with no bridges. So signing in Solidity, if we go through super quick example, which we're getting some random entropy, generate the signing key, and then sign it. And there's a variety of different algorithms supported. You refer to the documentation or ask on Discord, and we'll certainly help you out. And verification is also really easy, but it's a bit verbose. But the more interesting stuff here is a little wrapper for Ethereum-compatible key pair generation. So it's called Ethereum utils. You say generate key pair, gives you the public address and the secret key, which you can then use to sign anything just as you would with MetaMask or any transaction. And this includes a little library for EIP155 compatible signing. So you can construct a transaction, use the key pair and address that you used previously, and return a transaction to the user that they might want to submit back to the chain or submit to another chain. Or you could use like a TOTP authenticated wallets where it will sign anything up to $10 per day. So quickly moving on to the Oasis Privacy Layer, which allows you to add privacy to existing dApps on most EVM networks. So it's convenient for cross-chain, and it allows some transparency where you want it without requiring you to make everything transparent. And it's a lot easier writing contracts with OPL than doing ZK snarks, for example. So again, the documentation is available for you. You use the Sapphire-contracts package into your dApp, and you can access the library through opl.sol. So under the hood, it's using the Seller IAM bridge, which the main chains that you can bridge messages to and from are Ethereum, Binance Smart Chain, Polygon, but also like Filecoin, ZK EVM, and ZK Sync. And it's quite simple to get started. So you've got the message bus interface, and you post messages through this. So if we look at an example of going from Binance Smart Chain back and forth from Sapphire, on Sapphire you register your endpoint, which is the method that's going to be called. And then on Binance Smart Chain, when you invoke the call Sapphire method, it calls post message, which invokes the previously registered message, and behind the scenes Seller IAM detects that you're making the call. It gets signed by the State Guardian network, then it gets sent over to Binance Smart Chain or Sapphire or vice versa, where it's executed by the Seller IAM executor. And supporting the stack that we have here, if you're not sure about using the public gateway, or you need to have higher reliability guarantees, using both ChainStack and Covalent, you've got data APIs to look up token balances, NFT data, and historical transactions. Both of them offer a free developer account, and these APIs also index most OPL-compatible chains. And with ChainStack, this is like an enterprise-grade hosted node. So as a developer, you've got the free accounts, you've got subgraph support, and unless you're doing lots and lots and lots of stuff, you're probably not going to run out of credits. But if you want to scale up, they can run hosted nodes. I think it's like $30 a month at the sort of starting price, but it goes up to however much. They'll do full infrastructure management for you. And I don't think I can do this today, the hands-on coding. But thank you. Merci. Yeah.
There's actually one question from the public, from YouTube. So someone's asking, imagine some project on Matic using OPL. So the relayer's gas should be paid in ROS?
Okay. So if you're on Matic and you're using OPL to execute transactions on Sapphire, then you'll be paying gas on Matic, and you won't have to pay anything on Sapphire at all. So in terms of like ease of use and like reducing sort of developer friction, you don't have to worry about the contract remunerating the other contract on Sapphire and vice versa.